All right, guys, we are back. We are doing mole-to-mole conversions here. We're talking about stoichiometry, and we're doing full stoichiometry now, okay? Rather than just our baby stoich that we were doing before. So, a chemical equation, right? We've been talking about our chemical equations. We have our balanced chemical equations. It's essentially a recipe for the reaction, right? So the coefficients in an equation tell us the amounts of reactants and products we need to make the recipe work, right? So reactants in an equation, reactant-specific ratios to produce a specific amount of products, right? So if we look at a recipe for sugar cookies, right, this is something that we're kind of familiar with, right? We have 3 eggs, maybe a cup of flour, 2 cups of sugar because we want it really sugary, and we're going to get 24 cookies, right? So if we simplify it, right, it would be 3E for eggs, 1F for flour, 2S for sugar, and 24C for cookies, right? So we mass it all out, right? It follows the conservation of mass, okay, good. But if we had to bake 48 cookies, right, rather than just 24, how many eggs do we need? Well, we need to double this reaction. But we can do this using a stoichiometry chain, okay? So 48 cookies is how many we want to get. I can use a conversion factor, right? This mole-to-mole conversion factor is what we are going to be using. So 48 cookies, well, I know 24 cookies comes from 3 eggs. Now I can see that my cookies are going to cancel and I'm going to have eggs as my unit that's left over. 48 divided by 24 times 3, I'm going to need 6 eggs, right? Any number on top, I multiply. Any number on the bottom, I divide. So if I look at this, yes, just intuitively, I would know, oh, I need to double my reaction, I need to double the number of eggs. But I can use my stoichiometry with my less familiar reactions, okay? So let's look at this calculation here, right? We've got N2 plus 3H2 goes to NH3. This is a really important reaction for us to be able to produce all the food because that's ammonia, that's a fertilizer. But we need to know how many moles of nitrogen gas we would be needed to produce 10 moles of ammonia. Well, I want to get to 10 moles of ammonia, right? What I can do is I can use the equation as a conversion factor, right? Use the mole-to-mole ratio. So 10 moles of NH3, I know that 2 moles of NH3 comes from 1 mole of N2, right? My moles of NH3 are going to cancel with moles of NH3. My moles of N2 are going to be left over. That's going to be the unit that I wanted to get to, right? Now I just need to do the math, right? My 1 and my 2 here come from the 1 that is in front of the nitrogen and the 2 that is in front of the ammonia. So 10 times 1 divided by 2, I need 5 moles of N2 to get 10 moles of ammonia, okay? So our coefficients from our chemical reaction, our balanced chemical reaction, give us the ratio between our moles, right? This is the mole-to-mole ratio that we need, okay? What's going to be really important is that we label our moles of our substances, right? It's not just a mole of something, it's a mole of NH3. It's a mole of N2, okay? We have to make sure that we label those units. So let's go on to the next page and look at some more practice, okay? So on here, right, we've got C3H8 reacting with 5O2. If it's reacting with O2, we got a carbon molecule. This would be a combustion reaction, okay? And if we look at it, CO2 and H2O, that's good. If I look, it is going to be a balanced chemical reaction, so that's good, right? With a balanced chemical reaction now, I can do my mole-to-mole conversions, okay? So 12 moles of C3H8 react completely. How many moles of H2O are formed? Okay, well, my 12 moles of C3H8, I'm going to make sure that I write my full unit. I need to do a conversion. So I put my bracket on there. I'm going to have moles of C3H8 down at the bottom. And what unit do I want to get to? Well, I can go moles of C3H8 to moles of H2O. Well, what's the mole-to-mole ratio? I have a 1 here, and I have a 4 here. So it's a 1-to-4 ratio. I can close that bracket. I got to the units that I want to get to, so 12 times 4, I'm going to produce 48 moles of H2O. Make sure that we write out our whole unit for all of our answers. And make sure that we write out all of our steps. If we had a math or a calculator problem, I will still give you credit if you write out all of our steps correctly, okay? So let's make sure that we're writing everything down. Let's look at another question here, right? If 20 moles of CO2 are formed, how many moles of O2 reacted? Okay, so I have 20 moles of CO2, and I want to get to moles of O2. Well, I can again use my mole-to-mole ratio. Let's put a conversion factor on there. I have moles of CO2, and I want to get to moles of O2, right? Well, my numbers that are going to go in here come from my equation. I know that 3 moles of CO2 get produced by 5 moles of O2. That I can close that bracket now. I get moles of CO2 canceling with moles of CO2, and I'm going to get to moles of O2. That's what I wanted to get to, so I can do my calculator, or I can grab my calculator and do my calculation now. So my moles of O2, 20 times 5 divided by 3, it's going to be 33.3 moles of O2, okay? Let's look at one more question, but we're going to jump all the way down to the bottom, okay? Each of these, I think, are mole-to-mole conversions. I think you can do those on your own. But what we can do is we can come down here to number 7, and we're going to talk about grams now. Well, we've talked about with our baby stoich, right? With our baby stoich that we can go from grams to moles or moles to grams, or we can go from moles to molecules, something like that, right? Now, we can go between our different compounds. But for us to go between our different compounds, right, going from grams of N2 to moles of NH3, right, we have to use our mole-to-mole conversions, okay? We can't just go grams to moles of something else. Whenever we change our compound, we have to use the mole-to-mole conversion, okay? So we're going to get to how many grams of N2 react when 3.5 moles of NH3 are formed. Okay, so let's start with our 3.5 moles of NH3. We can use our conversion here. We have moles, so I can go from moles of NH3 to moles of N2, okay? Whenever I change compounds, I have to use a mole-to-mole conversion, okay? The numbers here now, let's look at my equation up above. Well, I know that 2 moles of NH3 get produced from 1 mole of N2. Now, I'm in moles of N2, and I can go to grams of N2, right? I'm not changing my compound, so now I can go moles to grams or moles to molecules, okay? So I'm going to get rid of my moles of N2, and I'm going to go to grams of N2. Mole of N2 to grams, this is my molar mass. This is just going to be 28 grams of N2. So now I got to the units that I wanted. So this is going to be my calculation here now. 3.5 divided by 2 times 28. If I do that calculation, I should get to 49 grams of N2. Okay? So let's go on. We can go on and work on some worksheets, some practice.